Hi guys, welcome to Code Solutions with me, Peculiar. Today we're going to be working on a very interesting code problem. We're going to be creating a user-defined function. I hope that you do have a memory of what a user-defined function is. Remember, within your C++ or any other programming languages, there are those defined functions like your cout, cin, your mathematical function, and many others. But for the purpose of this function, we will not be using predefined functions to solve our problem, but we will be creating our own function. And this is the program we're going to be working on today. The following formula gives the distance between 2 points, x1, y1, and x2 and y2 in the Cartesian plane. We probably are familiar with this equation. Given the center and the points on the circle, you can use this formula to find the radius of the circle. Write a program that prompts the user to enter the center and a point on the circle. The program should then output the circle's radius, diameter, circumference, and the area. Your program must have at least the following functions: the function A, distance, the function B, your radius, function C, circumference, and lastly, the function D for calculating your area. Your distance function will take in as its parameters 4 numbers that represents the 2 points in the plane and returns the distance between them. And the radius function will take as its parameters 4 numbers as well, and they will represent the center and a point on the circle. The function will call the function distance to find the radius of the circle and returns the circle's radius. And now our circumference function will take in as its parameters the number that represents the radius of the circle and returns the circle's circumference. And we're being told that if r is the radius, the circumference is, we obviously know that it's 2 pi r. This basically gives us the equation for calculating the circumference. And now to calculate the area, the function takes as its parameters a number that represents the radius of the circle and returns the circle's area. If r is the radius, the area is pi r squared, also giving us the equation we will use to calculate the area. Very, very interesting. What you need to do is to create a code problem that will mimic a calculating program for the distance between 2 points in a Cartesian plane, being your center and a point on the Cartesian plane. But then this calculator will calculate your distance between these 2 points, the radius, the circumference, and the area. But now, unlike when you were not using a user-defined function, you'd have all these operations within your main function. But now we are going to create 4 separate functions within our code to perform these operations. Let's clear off whatever we have in this compiler. I am using an online compiler today, and first things first, let's declare whatever library we may need for the purpose of our problem. So given our code problem, we see that we've got square roots. Within C++, we've got a predefined function which enables for us to work with square roots. Function is found within the library cmath. And remember, we're telling the preprocessor, hey, get us a library, cmath. Within the cmath library, there are functions which we may need. If we don't include the cmath function, we may need to create a function, a separate function, which will enable the compiler to know that, hey, this is a square root. Remember, this is a machine. It doesn't understand human language. So C++ has made it easy for us to work around this so that you don't have to bang your head around this, trying to figure out how you create a square root. Tell the machine that, hey, I'm trying to find the square root of a value. Right, so this seems like the only variable which we may need to use for the purpose of this code problem. Right, now we're using namespace. Great. Now to declare whatever which we may need, variable which we may need to use for the purpose of our code problem. So we will need to work with the variable x1, x2, y1, and y2. Also, we need to give variables which will hold the distance, the radius, the circumference, and the area. But remember, these values could come out not as integers. So let's store them in the double data type. going to have all these variables declared as a double. After all, your point in a circle could also be a 12.5, a 15.2, and the like. Great, now we have declared all the variable holders for all the values which we are going to be working with in our code problem. And again, we're working with functions. So let's also declare these functions which you're going to be working with. And remember, declaration of the functions is done outside of the main function. Okay, so let's firstly declare the distance function. We are told that it takes in as its parameters 4 numbers that represent 2 points in a plane and returns the distance between them. So because we're already working with a double data type, we're going to keep up with that. The data type of our function will be double. The name of our function, we'll name it, we can't name it distance. We already have the name distance already. So let's say dist. We are told that this function takes in its parameters 4 numbers, which represents 2 points in the plane. These 2 points in the plane being your x, y for the first point, and the x and y for the second point. I'll use capital letters instead of small letters because in the main function we use them as capital letters, small letters. Great, now we have declared our first function. Second function, we are told that this radius function also takes in its parameters 4 numbers. Interesting. Oh, one mistake which we did on the first declaration was we don't put in variables, but we rather just, because this is just the declaration, we just rather mention the data type of whatever that we'll be using, like this. Just like that. And then when we get to work on the function, that's when we will be mentioning that, hey, these are the names of our variables. Now let's declare the third function, the circumference function. This function takes in as its parameters a number that represents the radius of the circle, so we only have one variable in this one. Right, the last function to declare. This function takes in as its parameters the number that represents the radius. This function as well also takes one number within it. Great, now we have done declaration of all the variables which we will use in this function. So whenever you call any variable, the compiler won't be confused as to what is this that you're talking about. Now, first things first, let's prompt the user for any input which you will need. Going back to the question, what does the question say? Which input do we need? The program prompts the user to enter the center and a point on the circle. Great. Now let's prompt the user for such points. Right, so having prompted the user to enter all this input, now what we will do is to create this function to perform the operations. Great, let's go out of our function and create these functions. First things first, let's create the distance function. Please note that I've put in cx, cy for the center of x, center of y, and px and py, the point on x and point on y. Right, now how do we perform these operations? We also told that this function returns the distance between them. So return distance. Please note the different naming. And because this DST is unknown, let's declare it here. Is equals to square root. Remember, it's already mentioned that we already have a predefined function which mimics that symbol, a square root, and also the operations that come with it. And this is how you see it. And had you not mentioned this CMath, this would give you an error because now the compiler would not know what this function is. So in our equation, we've got two brackets, and these two brackets are being added, hence this addition sign which I've put in here. So what happens in the left side of the equation? Let's put a brackets for those, whatever that happens on the left side. Square of all of this. Interesting. How do you create a square? In the same library, CMath, we've got a predefined function which enables for us to do your powers. And this is it. This is this power. So now in our power, because we have the power to what? To 2, this is how we have our equation. On the left side, you will have whatever is being powered to 2. So now in our case, what is being powered to 2? Put it in brackets. It's x2 minus x1. Because in our case, we've got the x's, our x's, px, and cx for the left side of the square root. But then now this time, it's not the x's which subtract one another, but rather the y. Perfect. Our next function being, before we move on to our next function, we have an error here. We didn't mention the name of the function, we just mentioned the data type. Work on the radius function. How did we name it? Rad. Our function takes in 4 parameters. Continue with the same naming because this naming only remains in the function. And this function of ours, this function calls the distance to find the radius of the circle and then returns the circle's radius. We just called our function because we know that the radius of the circle is that distance. Hence, we told in the question that this function called the distance function to find the radius of the circle. Remember, we took the center and a point in a circle. Right? Great. Now create the next function. And this function, what does it return? The circumference. That the circle's circumference is 2 pi r. What is pi to the compiler? So let's declare this function here. Variable pi. Now we've created our circumference function. Last but not least, the area function. And what does it return? It returns the area. To declare this, squared. Another mathematical operation. So it's pi times r squared. Remember, we use power to do the powering, and then what is being squared here? It's rad. It's being sent to power 2. Notice something here. Because we have pi in this function and that function, we could declare this pi as a constant outside at the top where we have declared our functions. Here, it's a constant. And because you're already given the number of the value of pi, we can do it just that way. Right, interesting. Now we have the function to do our area as well. Pi rad divided by 2. And we have completely performed our operations. But now we just created the functions. We haven't even called them in our main function. But we're not just going to call them. Then we were just following instructions to create them. But then how do we call them? The program should then output the circle's radius. That's the first thing to output. Okay. Let's call the rad function. We've already declared the value that will hold the radius. Paste it here. But then this value is the one that will call the radius function. Rad within it holds 4 values, which is your center, x and y, and your point, x and y. So how did you call them here? Our center, x and y. Let's be careful of how we mentioned here. Cx, it came cx and cy, which means center x, center y, which was our x1, capital X1, and capital Y1. And then what came next was px and then py, which is our small x1, small x2. Great. So basically what we did here is, after you've prompted the user for input, we told that you should perform your outputting. But then this is the value which we said will hold the final radius from the function calculating. So now, next, what we are told that the program should output the circle's radius, the diameter, the circumference, the diameter, circumference, and lastly, the area. Right, now moving on to diameter. What will our diameter be? Our diameter will be whatever value we have times 2 on the radius. So we can just basically say 2 times radius. Right, let's put it in brackets. What's next? The circumference. And let's go call this function circumference. Radius. Remember in here the radius is this value, right? Okay, not as it was named in there. The area. Great, we already have the area there. Now it's all fun to say we have completed doing our code problem. Let's test it out and see if we have any errors to sort them out. Okay, we have error on line 9 to begin with. We didn't declare our capital lettered x's. Capital X1, capital Y1, and we have small x1, y. Okay, let's run our problem one more time. We've got an error on line 27 and 29. This should have been a 1. 27 and 29, what do we have? Oh, this red should have been a radius. Let's run it to see. More errors. Seems like we have in declaration errors. See? Let's go through our code one more time just to see if we have any declaration errors. Great. So we've sorted out whatever errors we had there. The errors we had was we needed to put in double in front of every variable we have inside of our parameters. So double cx, double everything in this function, double. Just double on your red. Just because it's up there in the declarative, it also needs to be in here. And we also had forgotten a semicolon over here. Right. So let's try out our problem question one more time. Interesting. Now I'll make it an easy one. So for the center, let's say we've got 0 points, just to make it easy for us to calculate through. Right, and say maybe the middle point will be 5:5. Perfect. Great answering. For our radius, we got 7.14, and the diameter is obviously the double of the radius, and the circumference what the calculator is telling me, and the area is perfect as well. Great. This was fun to do. I hope you understood and followed along. There's no wrong in you going through the video a couple of times to just eventually get to understand it. Nonetheless, see you on this upcoming video where we learn another new technique in coding with